Okay, hey students, it's Mr. Nairn. So today in class we didn't have enough time to go through both of the problems that I really wanted to review. So we did number 3 in class. I'm going to go ahead and talk about number 4 in a minute. But another student asked, they said, Mr. Nairn, could you go over number 5 on the other worksheet? So this worksheet is Unit 1, Worksheet 2, Average Velocity. And it's talking about a bear that's chasing a tourist, like they do. No, they don't. So it says the tourist is being chased by an angry bear and they're running in a straight line towards the car at 4 meters per second squared, or at least the tourist is. So his or her speed is 4.0 meters per second, and the car is a distance d away. So they're giving us a distance in a way, and it says the bear is 26 meters behind the tourist and running at 6.0 meters per second. Okay, so the bear is a little bit faster. The tourist reaches the car safely. What is the maximum possible velocity for D? So, like, what is the biggest distance that D can be and the person still survives? Because the bear is faster, the bear is going to catch up to him eventually. Okay, so let's go ahead and make a couple lists like we do. I've told you guys that my expectation is that you make a list of information. We don't really need a coordinate system for this problem because if they're going in a straight line, the bear is obviously going the same direction the tourist is, so we don't have to worry about positive or negative or anything crazy like that. Okay, so in my first list, I'll make a list of the tourist's information. Okay, so the tourist, if we're looking at that, one of the things I can go ahead and write down is that the displacement, I'm just gonna represent it with an X, but basically the displacement of the tourist we know is going to be equal to D, this distance that the problem is giving me. So if the problem's saying, yeah, you're going to go a certain distance D, that is the total displacement that the tourist is going to have. Now, another thing that we know is we know the velocity of the tourist. Now, I'm not, sorry, I said F, I meant to say T. We know that the velocity of the tourist is going to be 4.0 meters per second. Now, because it doesn't say anything about the tourist speeding up, it doesn't say anything about the tourist slowing down, we're going to assume that is a constant velocity. So I'm just going to represent it as velocity, subscript T, so I know the difference between the velocity of the tourist and the velocity of the bear. Another thing I want to write is the total, the time of the tourist, which we don't actually know. It doesn't say anything about time. So we're going to have to figure that out. Now, I want to make another list for the bear. Okay, so over here, I'm going to make some information about the bear. And the bear's displacement, okay, so this is x subscript b. The bear's displacement is going to be the same distance d that the tourist is traveling. Okay, remember we're talking the biggest distance that it can be, and he still gets there. So it's going to go the same distance that the tourist goes, but the bear also has to go 26 extra meters. So because the bear starts 26 meters away from the tourist, they have to go the 26 meters in order to close the gap. But also, that whole time, the tourist is heading towards the car going a distance d. So you have to add them both up over here in the bear list. Let me go ahead and get velocity of the bear written down, just so I have everything organized in this list. Okay, time of bear, we don't know what it is. And so as we can see, we're only given velocity, displacement, and time for both of these objects. And so if you're looking at your equation sheet, hopefully you're realizing, hey, we have an equation for that. So V equals x over t. I'm taking the delta away. I don't want to make this overly complicated, but basically velocity equals displacement over time. Now, here's something that maybe you notice. We don't know time for either of these things. Okay, we don't know time of the tourist, we don't know time of the bear. But what we do know is, you've got to think, tourist is running, 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 bear's running, running, running. We know that eventually the bear's going to close the gap. Okay, you can look at my little camera down there. Eventually the bear's going to close the gap. So the time it takes for the tourist to reach the car is like snap jaws right behind him. The bear's amount of time it takes to reach him. So what that means then is that even though we don't know either of the times, what we do know is that they are going to both be equal to time t. So basically, they will both reach the car at the same time. Now, let's not get into semantics. Well, Mr. Aaron, if they reach at the same time, that means the bear eats him. Okay, we're going to say like basically at the same amount of time. Okay, but otherwise the problem's unsolvable. So this is a pretty big assumption we have to make, but that's the best that we can do. So what that means then is that if I rearrange this equation, okay, solving for time, which you can do that algebra on your own, but basically you just flip them. So time is equal to displacement over velocity. And so now that we know that, let's go ahead and write down our specifics for the tourist and our specifics for the bear. So time of tourist is going to be equal to distance d. I'm going to go ahead and plug in for x. Okay, we know that x of the tourist is going to be that distance d that the problem gives us, divided by the velocity of the tourist. And I can do the same thing with the bear. So time of the bear is going to be equal to, now remember, displacement of the bear is distance plus 26 meters. And this is all going to be over velocity of the bear. So again, I'm just taking the information, sort of, I don't want to plug in velocities yet, but I'm taking the information that I have up here in my list and I'm putting it down below. Because now that I've done this, okay, now that I've done this, because of what I said, that they're both equal to time t, I can set them equal to one another. So basically I'm going to do, all right, t, time of tourist is going to be equal to time of bear. So I'll just set the two equations equal to one another. And then we can start to do some algebra. Okay, there we go. All righty. So let's do that. Let's do that. So basically I'm going to say, all right, well, distance over velocity of tourist is going to be equal to distance plus 26 meters over velocity of bear. And if we didn't have that addition in the numerator, it'd be a pretty easy problem, but it's still, I mean, it's still not that bad. I'm going to go ahead and break this up into two fractions over on the right side. So I'm going to go ahead and separate it out and make it distance over velocity of bear plus 26 meters over velocity of bear, because that'll allow me to at least get one number here in a second. So see, I just broke the fraction up. Not a big deal. Okay, we're not reinventing the wheel. So now what I want to do is I do want to go ahead and plug in values, because as soon as I do, I can start to simplify this just a little bit. Okay, so I'm going to plug in values from above and write this in simpler terms. So still going to be d. We don't know what d is, so I'm just going to have to rewrite it as d down below. Velocity of tourist, I can look back at my list, and you can look at your list and see velocity of tourist is 4.0 meters per second. Still have distance d over on the right side. Let's give OneNote a second to catch up to me. Still going to have distance d over on the right side, but now it's over the velocity of the bear, which is 6.0 meters per second. And this is going to be plus 26 meters over 6.0 meters per second. Okay, so again, I'm just plugging in all the numbers that I can. I always recommend you do as much algebra as you can do with just the letters, okay, just with variables, and then plug in numbers when you absolutely have to. So at this point, this is the point when we have to. Another thing I'm going to do, and I only do this sometimes for algebra reasons, is and I hate to do this, I'm going to drop units for simplicity. So I'm afraid you guys are going to get too confused if I just keep all these units around. So what I'm going to do is I'm going to go ahead and drop the units just to make it a little bit cleaner, a little bit easier to understand. I'm still going to keep up with my sig figs. Don't worry about that. But now that I've done that, let me show you what I've got. So now I have d over 4.0 is equal to d over 6.0 plus, I think you end up getting 4.33 repeating. I'm just going to write it as 4.3 for right now. Okay, and so we end up getting this because I did 26 divided by 6. That's where the 4.3 comes from. Okay, and so at this point, we need to go ahead and try to start getting rid of some of this stuff. So first thing I'm going to do, I'm going to multiply the whole right side times 6.0. And again, as you know, if you multiply one side by something, you got to do the same thing to the other side. So I'm going to multiply both sides by 6.0. That's going to help me get rid of that fraction. Okay, and so by doing that, this is what I end up getting. Now I have 6.0 times d over 4.0 is equal to d plus, by the way, 4.3 times 6.0 basically ends up getting you 26 again. We're basically going back to that fraction from before. But yeah, 4.3 times 6.0, near as makes no difference, gives us 26. So we're going to round it up to 26, still maintaining two significant figures. And now, I think you know what's probably coming next. We're going to get rid of the fraction over on the left side. Problems are so much easier when you can get rid of fractions. So over here, I'm going to multiply everything by 4. Over here, I'm going to multiply everything by 4. Whatever you do to one side, you have to do the other side. So by multiplying both sides by 4, we can get rid of that fraction. All right, let's get everything cleaned up and see what we got. On the left side, we just end up getting 6.0 times d. On the right side, I have 4.0 times d plus. Now I have to do 26 times 4. and I end up getting 104. Now, this leads to a little bit of an issue, a little bit. But the thing is, technically, if you're following significant figures, 104 should get rounded to 1.0 times 10 to the 2 meters, which we can't really do without getting some pretty bad rounding issues. So here's what we're going to do. You guys have seen these numbers the entire problem. You got 6.0, 4.0, 26. Let's just make our final answer 2 sig figs, and let's just not worry about it right now. Okay. So the next step I'm going to do, I'm going to go ahead and subtract over 4.0 times d. Okay, just to get rid of it on that side. Whatever you do to one side, do to the other. So I end up getting this. I get 2.0d equals 104. Obviously, we're going to divide by 2 on both sides. Oh, sorry. Let me scroll down. Apologies. So we end up getting this. Yep, 2.0d equals 104. Divide both sides by 2.0 so I can cancel it on this side. And then finally, we get our answer. D is equal to 52. See, 2 sig figs. It's going to work out. But D equals 52 meters. Now, you're probably saying, well, Mr. Darren, how do you know it's meters? If you really want to go back and do unit analysis and basically plug in units everywhere where I didn't, you can. Or you can just trust me and know that we did what we were supposed to because we didn't break any rules of algebra. But you should know that meters is the unit for distance. And so that's why I'm comfortable just plugging that in. Okay, so 52 meters, that's the unit for distance. And then you want to put a box around your final answer. Okay, so there you go, guys. There's problem number 5. The other question that was asked was on unit. Oh no, my answer's already here. Let's delete that because I want to solve it with y'all. Sorry, I did it last night and I want to do it again now with you guys. So let's look at number 4. This is the other one that was requested. So it says in a historical movie, and notice historical is in quotation marks. 2 knights on horseback start from rest 88.0 meters apart. So that's a number we definitely want to know. Let's highlight that. And you guys don't have to highlight. I just think that it's useful. I know we're going to end up making a list anyway, but that just helps me keep track of what I'm doing. So they start from rest 88.0 meters apart, and they ride directly toward each other to do battle. Now, the reason this is important, I'm not going to highlight it, but the reason this is important is we're going to end up making one of them have a positive acceleration. We're going to make the other one end up having a negative acceleration. Okay, we have to do that. Okay. Next, Sir George. He has an acceleration of 0.300 meters per second squared. Hopefully you're thinking, all right, how many sig figs is that? That's 3. While Sir Alfred has a magnitude of 0.200 meters per second squared. And again, how many sig figs? It's 3 sig figs. So already, just because and also 88.0, 3 sig figs, already I know my final answer is going to have 3 significant figures. It's just going to. So I'm not going to worry about it too much. I'm going to still keep track of it, but at the end, I know it's going to have 3. Relative to Sir George, now that's kind of important. Okay, we're going to base everything off Sir George because that's what the problem's looking for. It says, where do the knights collide? And I said graphs are helpful. That was back when I taught this the first time. I'm going to go ahead and tell you guys, we need to do this the algebra way. So that's what I'm going to do. So yeah, you could use graphs to do this if you're really smart, but I would rather you did it with algebra. So that's what I'm going to do. Okay, guys, here we go. Let's go ahead and make a list for George. Okay, so I'm going to do acceleration of George was given. And because the whole problem is based off George, let me zoom in and square this up a little bit. Because the whole problem is based on George, I'm going to make his acceleration positive 0.300 meters per second squared. So he's going to get the positive acceleration. And we're going to also say G begins at a position of 0. So he's going to start at the starting point, or what we're going to consider to be the start point of 0. All right. So he starts at 0, moving in the positive direction. So what that means then is Alfred is going to start 88 meters away and is going to be going in the negative direction. All right. We'll talk more about that in a second. Now, another thing that we know is we know that, well, I can go ahead and write it this way, I guess. Initial position, I just wrote it, but let's say x naught. So we know we're talking about initial position of George is going to be 0.00 meters. I'm just maintaining 3 sig figs. That's why I wrote it that way. Another thing that we know is because it says in the problem, they start from rest. So whenever you hear that word rest, start from rest, that means that initial velocity is going to be 0. And George is no different. So V naught for George is going to be 0.00 meters per second. And once again, rest from rest is technically infinitely significant, but I still want to make it have 3 sig fig, so I'm just going to write it as 0.00. That's fine. Okay, what else do we know? Nothing for George. So now let's look in terms of Alfred's perspective. So acceleration of Alfred, I already told you that Alfred is going to start away. Okay, in fact, let's write it that way. Let's say A begins, handwriting. A begins at a position of x equals 88.0 meters. In fact, I'll go ahead and write it. X naught for Alfred is going to be 88.0 meters. Okay, there we go. And because he's starting away, that means he's still going to have the same magnitude. I'm not changing the magnitude of his acceleration, but I am going to give it a negative sign. So it's going to be negative 0.200 meters per second squared. Okay. Also, Alfred is also starting from rest. So V naught for Alfred, V naught A is going to be equal to 0.00 meters per second. Okay. Give OneNote a chance to catch up. I'm going to get a little sip of water. There we go. It's going. It's going. There we go. So guys, this setup right here is the biggest, most important part of this problem is, can you identify what your variables are? Can you physically think about it and put them in their places, assign them the values that they need to have? Because the thing is, the problem only gave us 3 numbers. But from that, this is all the information I was able to glean. Now, this is why this is important. Okay, this is why this is important. Notice I haven't said anything about time yet, but think about it. They're going to be going the same amount of time until they collide somewhere in the middle. So as I look at my equations that I have, I know that I'm looking for where the knights collide. So somewhere in here, I'm going to be looking for x final. I'm looking for the final position of both of these relative to George. So we're really looking for him. But because of that, I know I'm going to use that. So if we look at our equations, the equation that fits here is actually this one. I'm going to write it for George first. So final position of George, which, by the way, that's the purpose of the whole problem. We're looking for final position of George, is going to be equal to x naught for George plus v naught times time plus 1/2 a t squared. And if you don't believe me, you can check your equation sheet, but that is an equation that you should be familiar with. Now, the reason I'm using this is it has time, and I know what you're saying. Well, we don't have time. Don't worry. I'm going to show you why that's important here in a second. We have xg, final position of George, that we're looking for, and everything else we know. So that's really helpful. Let me go ahead and write it for Alfred as well. Now, Alfred's is going to be just a little bit different. Okay, his is going to be a little bit different. Why did I write it like that? Oh, that's why. Okay, so x naught for Alfred, final position for Alfred is equal to, now watch this, x naught a, which we do have a value for, we're going to do in a second, plus v naught a times time plus 1/2 a t squared. So same equation, we are going to plug in some slightly different numbers. Okay, so now that we've got everything set up, notice I'm still following the 5 steps. Step 1, what are we given? Step 2, what are we looking for? We know we're looking for a final position of George. If it makes you feel better to write it out, here you go. xg, what is it? We don't know. That's what we're looking for. We've now written the equation in letters only, okay, for both of them. And so because we don't know time, but because we do know that they're both going to hit at the same time, I'm going to be solving for that. But first, let me show you a little bit of math. Okay, looking at our lists. Okay, let's look at George first. Initial position for George, it says is 0. So basically, I'm just going to make this go to 0. Okay, initial position of George is 0. I'm just going to make that term disappear. It's going to make our algebra easier. But wait, there's more. Initial velocity for George, v naught g. That is also 0. So this whole term right here is also going to go to 0. And the reason that's significant is now I can rewrite this and it looks a whole lot better. Okay, it looks a whole lot better. So now I can just say this. 1/2 AG, there we go, times T squared. There we go. Now, I'm going to do something similar over on Alfred's side. It's going to be a little bit different though. So, for instance, if I'm looking at X, his initial position, it's not going to be 0. We can see up above, though, it is going to be 88.0. Remember, X naught means initial position. And what we said for Alfred is that he's the one that's starting 88 meters away. He's the one that's starting 88 meters away. Next, initial velocity is still 0. Oh, I forgot a plus sign. Put a plus sign in there. Squeeze it in. There it goes. Okay. Because this next term is also going to go to 0. Initial velocity of Alfred is also going to be 0. So that whole v times t term goes away, goes to 0. So that's helpful. So let me rewrite this now with just one number. We don't want to get too carried away. And I know what you're thinking. Mr. Nairn, can't we go ahead and plug in acceleration too? You can, but let's not. Okay, only plug in what's necessary. And this is what I'm considering to be necessary for right now. Okay, so writing it a little bit simpler. Now, it's at this point that it's really important that you guys recognize that they are going to hit at the same time. Okay? So here's some things that you need to consider. Okay? Thing number 1, T is going to be equal to time of Alfred. It's going to be equal to time of George because they're going to collide at the same time. That's going to be really important. And another thing that we know is their final positions are going to be the same. Because think about it, they collide. They start away from one another, but they're going to collide somewhere in between. And when they do, they're going to share the same position. Even if one starts at 0 and one starts at 88, they're going to share the same position somewhere in the middle. So what that means then is xg is going to be equal to xa, which is going to be equal to just x. Let's just call it x with no subscript. Okay? Collide at the same position. So I'm going to write it this way. Same position at collision. And by the way, guys, I know that you're saying, well, Mr. Nairn, do we have to write all that? I recommend that you do. You need to get in the habit of explaining your procedure and your rationale, because on the final exam, they definitely want you to explain what you're doing. They don't want you to just do a bunch of math. So any captioning, I call this captioning, any captioning you can do saying, look, I'm setting this equal to this because of this. I'm setting this because of this because of this. See, I'm not writing much, but that captioning could be a huge difference maker on the final exam. So why do we care, Mr. Nairn? Well, now we're going to solve both for t, all right? Solve both for t, and then we can set them equal to one another, okay? So we're going to solve both for t, and then we're going to set them equal to one another. Let me let OneNote catch up real quick, and then I'll show you. Or rather, pardon me, let's not solve for t. Let's keep it even simpler. Because as you can see, there's going to be a t squared. So instead of messing with square roots and stuff, we could actually solve them both for t squared. Because think about it. If t is equal, t of Alfred, t of George, just the same, is equal to t, then t squared is going to be the same too. So we can actually solve both for t squared and make it even easier. I remember doing that. Okay, so for Alfred, we end up getting this junk. And you can check my algebra on your own. I was able to kind of do this in my head, so let's do that here. So I end up getting all this. I'm gonna do the same thing for Alfred. OneNote's kind of keeping up with me. You know what? I see how I did it last night. I think I can actually do it easier this way. Let's not solve both for t squared. Let's solve just the one on the left for t squared. And then what we'll do is we'll do a substitution. So let's solve this one for t squared, and we're going to do a substitution. So now what I can do, we'll sub into Alfred's equation. And I'll show you what I mean. That'll keep things a little bit nicer, actually. Oh man, and I wrote it as xg, and I told y'all not to do that. I'll fix it in a second. So here we go. X Alfred is equal to 88.0 meters. See, I'm just carrying it down from above. I'm using that from above, but instead of writing t squared this time, I'm actually going to plug in what I just got from Alfred's equation. Okay, let me fix that because I messed up that. There we go. Okay, x equals 88 plus 1/2 a times, now I can do my plug-in, 2xg over ag. There we go. I like that better. Oh no, OneNote, now is not the time to start screwing up. Can you please keep up with me? Sorry guys, I didn't notice it was doing that. And if there was a way to pause my recording, I would, but I don't know how to do that with OBS without it just completely stopping. So hold on, let's give it a second to catch up. I don't know why it stopped all of a sudden. Just give me a minute. I may have to restart the app. Very interesting. I see no reason why it shouldn't be going. I'm sorry, guys. Luckily, you have YouTube, so you can skip ahead just a little bit until you see me start to write stuff again. So if you're watching this in the future, just fast forward. Just don't dislike my video. That'd be rude. Come on. It is not synced because I've written a bunch of junk on it. Come on. Okay, let me close this app and reopen it. I'm doing all the things that I know to do. They usually work. That is really frustrating, y'all. I wish I knew what to tell you. I still got to teach 2 classes today, so there's a chance that it's going to be annoying for those classes too. I apologize, 3rd and 4th period. I hope not. It might be. Nothing. I'm just going to wait, but like I said, you guys in the future can just fast forward ahead to the point where this actually does start working. I have no explanation for why it's not doing its job right now. Yeah, I don't get it. I do not get it. Oh, we got an error. That's cool. That's really helpful. Come on. See, the thing is, it has a little X right here, which makes it seem like there's an error. Oh, there it is. There's the saved offline error. Can you try again? There we go. All right, we did it. So I changed a couple things. Let me explain what we're doing, just for those of you that have forgotten. So basically, we solved for all this stuff. We solved for t squared right here, as we can see. And so now that we've solved for that, because time is the same for both of them, because they're going to hit at the same time, I'm just going to do a substitution in, and I'm subbing that into George's equation over here. All right, so I'm subbing that over here. Or Alfred's, dang it. Subbing it into Alfred's equation. I was right the first time. So anyway, now that we've done all that, yeah, now we're good. So now that we've done all that, it looks like OneNote is ready to play again. So let's actually get going. And I do apologize for the glitch, but luckily you guys can fast forward because this is on a YouTube video. One thing I want to do that I just said I was going to do and I forgot is I'm going to go ahead and change X Alfred, XG, and X. I'm just going to rewrite it all as X. The reason I want to do that is whenever you can say, like, hey, this thing is also equal to this thing. If you can ever like parse it down where instead of having two separate variables, you make it one variable, you always want to do that. And so that's what I'm going to do right now. So I'm going to rewrite this instead of XA, I'm just going to write it as X. I'm going to rewrite 88.0 meters plus 1/2. A of A is still acceleration of Alfred. But now this is going to be 2x. Oh, come on. Over AG. And it looks like we're running into problems again for no foreseeable reason. My internet is fine. There we go. Come on. It's not all I wrote. Come on. It's almost like the OneNote server sometimes just gets like overwhelmed and it can't keep up with me. Okay. So now that we've done that, we can do a little bit more algebra. So the next step that I want to do is I can go ahead and get rid of 1/2 and 2. So if I'm only looking in this last term back here, so if I'm only looking at this last section back here, 1/2 times 2, that just ends up going away. So I can get rid of that and clean this up a little bit. So let me rewrite it down below. So now I have X equals 88.0 meters plus AA times X over AG. So that helped us simplify quite a lot. So just being able to get rid of that 1/2 and that 2 makes things a lot easier. So we end up getting this over on the other side. I want to get all my X's in one place. Okay, so I'm going to subtract this whole term over to the left side. Okay, so I'm going to subtract it to get rid of it. Whatever you do to one side, you have to do the other side. So we end up getting this. Okay, you end up getting this mess. And those of you that are really good at algebra realize that you can factor out this x. So that's what I'm going to do next. Okay. Factor out x, because that'll make things easier. And so then I end up getting this. 88.0 equals x times 1 minus AA over AG. There we go. See, well, now OneNote's doing okay. So now that we have this, the reason this is important is I can rewrite it to give them a common denominator. So I'm still dealing with those hateful fractions. Nobody likes fractions. But the fact that I have those fractions means that I can make that a common denominator. Because the thing is, AG over AG is the same thing as 1. So I'm just going to rewrite that, okay? So basically I'm going to do this. 88.0 equals x times AG over AG. I'm going to get a common denominator. That's legal. 1, it's the same thing. I'm just rewriting it a different way. I'm writing it as AG over AG because now I can combine those fractions. Okay, it's going to make my life just a little bit easier. Not great, but a little bit. And so we end up getting this. And the thing is, I know that some of you are probably really good at algebra. And you're probably far ahead of me by now because you started working way back when we started having the glitches. But as for the rest of you, I'm doing this for you. So those of you that struggle with algebra like I did when I was in high school, this is for you. So you can try and start to get used to it because you're going to have to do it. Let's go ahead and divide the x over to the other side. Okay, I'll show you what that looks like. So if I divide by x on this side, I divide by x on this side, it's going to cancel it, which is a little bit helpful. But I'm also wanting to get rid of 88. Basically, I'm trying to get x on one side by itself. Okay, and so at this point, this is what I would have. Let me let OneNote catch up real quick. Hopefully it will catch up. You know how it's acting today. Not much I can do about it. There we go. So see, I've got 88 over x on the left side, and this is equal to just that fraction we had from before. Now what I'm going to do, because I want x by itself, is I'm going to divide out 88. And that's going to cause just a little bit of an issue, but it's not going to be that bad. You guys will see. So I'm going to divide out 88. Okay. And let me show you what this ends up looking like. So because x doesn't just become just regular x, that's not how it works. What it does give you is 1 over x because it leaves that 1 behind when you divide out the 88. Okay, so you end up getting this. Scroll down just a bit so I got a little more room. And this is going to be equal to, technically, I'm going to rewrite it like this, a over g minus a over a over ag. It's 1 over 88.0. And now we can do an inversion. So basically, I'll invert both sides here in a second. That'll straighten out x and give it so I have x by itself again. And that's going to make our lives a lot easier. There we go. Where's my 1 over 88? Load it. I wrote it. You load it. We're almost there, guys. We are almost there, and we'll be done with this hateful problem. 1 over 88.0. There we go. And by the way, this is meters. I dropped units a little bit back, but we know it's meters. Here you go. I'll rewrite it again. And now what I'm going to do is invert both sides. So basically, if I do both sides to the -1 power, that flips everything on both sides. And that's going to make it look a lot nicer. Let me show you what I mean. So that ends up giving me just regular x. Okay. It ends up looking like this. And at this point, it would be reasonable to plug in values because look, we have our unknown x, the final position on the left side. And again, remember, it's relative to George, in case you've forgotten, because it's based off 0, an initial position of 0, and that's where George started. So we have x on the left side by itself, and we have all these things that we do know over on the right side. So I'm going to go ahead and start plugging in values, and then the pieces are going to come together. And I do apologize for the glitches. I wish that I could explain why it does that, and I can't. All right, so AG, I got to look back at what I wrote, is positive. Now be careful with this. Positive 0.300 meters per second squared. Okay, I'm going to plug that in for both of those. And remember, Alfred's acceleration was a negative 0.200 meters per second squared. So we end up getting this times 88.0 meters. And at this point, I think you know. You just plug it in your calculator. Okay, just going to plug it in your calculator. Be really careful with your order of operations here. If you're not careful, you're going to end up getting the wrong answer. So either do it in pieces, or you better be really clever with how you use parentheses on your calculator. I ended up getting 52.8 meters. And remember, this is based from George's starting point, where he started at x equals 0 meters. Put a box around it, and that's finally done. So guys, again, I do sincerely apologize that we had some technical issues. I don't know what's going on. I think I'm going to go reset my router for my next 2 classes, but I hope this was helpful for you. If you guys have questions, remember, send me an email called Q&A session topic, and then I can go over it in the class time that we have over the Zoom. Thank you very much. Have a great day.